This is Professor Antonio S. Marajas, and this is Advanced Digital Technique. So we go now to simplifying logical equations. And one way of simplifying logical equation is by using the Karnaugh map, or we call it the K map. The K map provides a graphical technique for reducing logic equation to a minimal form. Okay? So, K map is an array of cells which contains all the information in the truth table, arranged in a way that allows a quick visual simplification of the logic equation according to some very simple rules. Now, the usefulness of the K-map lies in the fact that adjacent cells can be grouped visually to eliminate redundant variables. Okay? So, we make use of K-map in simplifying equation, regardless on whether it is in the form of sum of product equation or in the form of product of sum equation. So, let's have a two-input variable map. Okay? The first rule for a two-input variable map is a group of two adjacent cells combines to yield a single variable. The second rule, a single cell which cannot be combined represents a two variable term. So these are the two rules in a two-input variable map. Okay, so let's say we have a truth table. Okay. So we have two inputs represented by A and B. And then let's say the output is represented by X. So what are the combinational values of AB? You have 0, 0, 0, 1, 1, 0, and 1, 1. Okay? Let's say from a particular problem, the output of X here is 1, 1, 1, and this one here is 0. So how do we obtain the simplified logical circuit that would represent this particular table? Okay, so we draw a map. Okay, so we have 4 cells. Okay, so why 4 cells? So because we have 2 input variables. So let's say you have 2 to the 2 is equal to 4. This one here now corresponds to the number of inputs or input variables. And then the value 4 here corresponds to the number of cells. Number of cells to satisfy a 2-input variable map. Okay? So what are the values of A and B? So for A, there are 2 possible combinations. You have 0 and 1. For B also, you have 0 and 1. Okay? So these are what we call cells. So the value of this cell here is what? Value of A is 0 and the value of B is 0, which is actually this one here. And here, this cell here has a value of A is 1 and B is 0. And that is this value. And then you have this cell here contains a value of A, which is 0, and B, which is equal to 1. And then we have here A is 1 and B is 1. Okay? Or we can also represent the map Okay, two variable input in this manner. You have A and B, again, 0, 1, 0, 1. So if we will use the sum of product expression, SOP, okay, that means that we have to consider the product term. So in this case, the product term, no? So in this case, if A is equal to 0, that means that the variable is complemented again. Then B is 0, you have B complement. Now here, since A is 1, so you have A not complemented, and B here is 0, so B is complemented. Then you have here A is 0, A bar, then B is 1, so you have B. And then the last one, you have A is 1, so you have A, B is 1, A, B. So if you notice that in this particular two cells here, the common variable is A bar. So that means that these two cells here belongs to A bar. And these two cells here, common is A. So in other words, these two cells here, it is represented by A. And then, in this case here, okay, these two cells here, the common is B bar. And this one here, the common is B. Okay? So in other words, this region, it is under A bar, and these two cells or region is under A, and these two cells here under B bar, and these two cells here is under B. Okay? Now, that is using the product term. Now, if we will represent the table now using our K-map, this will be our K-map, representation of the table. A, B again, 0, 1, 0, 1. And we know that this is now under A bar. This is under A. This is under B. And this is under B bar. Then we locate the output X here in our map. So if we have A and B are 0, 0, 0, A, B 0, the output is 1. So you place 1 there. Why use the 1? Because you're using the sum of product expression method. Okay? Then we have here 0, 1. Where's the 0, 1? A is 0, B is 1. 1 or 0, 1. And then next is the next is 0, 1, and then next is 1, 0. 1, 0, so you place a 1 here. Okay? Then according to our map, according to our rule, a group of two adjacent cells combines to yield a single variable. So what particular cells here are adjacent? Okay? So we have here, this one here, and this one here is what we call adjacent sets. So we can combine them into one group. Okay? This cell here and this cell are not adjacent. So delete pwede. Now, what is remaining is this particular cell. And this cell here is still adjacent to this cell. Even if this cell here have been grouped in this particular manner. But since this cell here is still adjacent to this particular cell and this cell has not yet been grouped, so we make use of this cell for our grouping also. So we have two groups, no? And we know that this particular group here belongs to what? This is under B bar. Okay? B bar. Why B bar? Because according to our rule here, a group of two adjacent cells combines to yield a single variable, and that variable is B bar because these two adjacent cells belongs to B bar. And this one here, these two cells belongs to A bar. Okay, so that our equation now becomes A bar plus B bar is equal to X. That will be our simplified equation. Now, how do we know that this is already a simplified equation? Because if we have here this table, if we will use the sum of product expression method in deriving its logical equation, this will be the logical equation. You have here A bar, B bar, plus this one, A bar, B, plus A, B bar is equal to X. This is the original equation, and once we use the K-map, this becomes its simplified equation. Okay, so here, if we will represent this with logical circuit, so you have 1, 2, 3 AND gates and 1 OR gate, right? And then here in the simplified logical equation, we will only be using OR gate. So even the logical circuit will be simplified because of the simplified equation which was derived. Now, however, if we have a sample here, which is this one, you have here one, and then another one here, okay? So these two cells are not adjacent, so they are grouped individually. So since they are not adjacent, okay? And we know that this one here is under A bar, and this is A, this is B bar, and this is B. So what will be our equation or variable term for this particular cell? Okay, so according to our rule, a single cell which cannot be combined represents a two variable term. And this one here, the intersection of this cell here is A bar, B bar. Okay, so the logical term is A bar, B bar, and this one here is under what equation? So we have A, B. Okay, so that our logical circuit or logical equation will be A bar, B bar plus AB is equal to X. That will be our logical equation, simplified logical equation. Okay, that is if this will be our representation in our K-map.